Hello everyone, welcome to our exploration of the circuit breaker pattern. As designers, we always seek well-established and elegant solutions to common problems. Cloud design patterns are the solutions that enhance your application with proven methods for scalability, security, and cost efficiency in the cloud. In this video, we will discuss a problem, present the design pattern solution, and understand when we can and cannot use this pattern. Whether you're a developer, an architect, or just someone curious to know about this design pattern, this video will provide you with valuable insights. My name is Madhur. Let's get started. Let's begin by setting the context and understanding the problem where you can apply this design pattern. In a distributed environment, calls to remote resources and services can fail due to transient faults such as slow network connections, timeouts, or the resources being overcommitted. These faults typically correct themselves after a short period of time and can be handled by using retry design pattern. I've already created a video on retry design pattern, link for which can be found in the description. However, there can also be situations where faults are due to an unanticipated event, which might take longer to fix. In these cases, it might be pointless for an application to continually retry an operation that is unlikely to succeed. So it's important to handle these scenarios effectively to ensure the robustness of the cloud application. To address the problem at hand, we can implement the circuit breaker design pattern. This pattern helps prevent an application from repeatedly attempting to execute an operation that is likely to fail. Additionally, the circuit breaker pattern enables an application to detect whether the fault has been resolved. If the problem appears to have been fixed, the application can attempt to invoke the operation again. To implement a circuit breaker, we need to implement logic to monitor the number of recent failures and use this information to decide whether to allow an operation to proceed or to return an exception immediately. Using the number of recent failures, we can put the connection into the following states that mimic the functionality of an electrical circuit breaker. The normal state of the circuit breaker is closed. At this state, the request from the application is routed to the operation. If the operation call is unsuccessful, the logic increments a failure count. If the number of recent failures exceed a specified threshold within a given time period, the circuit enters the open state. At this point, the logic starts a timeout timer. When this timer expires, the circuit transitions to the half-open state. The purpose of the timeout timer is to allow the system time to fix the problem that caused the failure before allowing the application to attempt the operation again. In open state, the request from the application fails immediately and an exception is returned to the application. In the half-open state, a limited number of requests from the application are allowed to pass through and invoke the operation. If these requests are successful, it is assumed that the fault previously causing the failure has been fixed and the circuit breaker switches to the closed state. If any request fails, the circuit breaker assumes that the fault is still present, so it reverts to the open state and restarts the timer to give the system a further period of time to recover from the failure. The half-open state is helpful to prevent a recovering service from suddenly being flooded with requests. As a service recovers, it might be able to support a limited volume of requests until the recovery is complete. The circuit breaker pattern is designed to provide stability while the system recovers from a failure and minimizes the impact on performance. It helps to maintain the response time of the system by quickly rejecting a request from an operation that is likely to fail, rather than waiting for the operation to time out or never return. If the circuit breaker raises an event each time it changes state, this information can be used to monitor the health of the part of the system protected by the circuit breaker or to alert an admin when a circuit breaker trips to the open state. Now let's discuss some of the issues and considerations for this design pattern. You should consider the following points when implementing this pattern. The first consideration is recoverability. Make sure to configure the circuit breaker to align with the expected recovery pattern of the operation it is safeguarding. For instance, if the circuit breaker stays open for an extended period, it may generate exceptions even after the underlying issue has been fixed. Likewise, if the circuit breaker transitions too rapidly from open state to half-open state, it can lead to fluctuating response times from applications. Another consideration is testing failed operations. In the open state, instead of relying on a timer to decide when to transition to the half-open state, a circuit breaker can periodically send a request to the remote service or resource to check if it has become available. Another important consideration is around replaying failed requests. in the open state. Rather than simply failing quickly, a circuit breaker could also record the details of each request to a storage and arrange for these requests to be replayed when the remote resource or service becomes available. Use this pattern to prevent an application from attempting to invoke a remote service or access a shared resource if this operation is highly likely to fail. This pattern is not recommended for handling access to local private resources in an application, such as an in-memory data structure. In this scenario, using a circuit breaker would add overhead to your system. It is also not recommended to use the pattern for handling exceptions within your application's business logic. If you found this video insightful, do share, like, and subscribe. Until next time, stay curious, stay data-driven.